Hi, Mr. Sapone here, and you've got 99 problems, and getting eaten by a shark is one. So this is my shark problem. I kind of like this problem a lot, and let's get to it. And this is the Are You Fish Food problem, and we're gonna do some speed, velocity, or speed, distance, and time, and we're gonna see if you get eaten by a shark. Suppose you are swimming in the ocean and you see the fin of a great white shark appear in the water 150 feet away from you. So you're blah, blah, blah. You're splashing in the water. You're having a good old time. You're cutting my science class. And you see the fin of a shark. Dun, 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 dun. And it's about 150 feet away from you. And you're estimating I'm about 40 feet from the shore or sandbar or safety, somewhere where the shark can't swim. And you can swim at 3 feet per second, 3 whole feet per second. The shark can swim at a frightening 35 feet per second. Will the shark be enjoying you as a tasty snack? Will you be fish food? And as you know, a yes or no answer is not going to suffice. You're going to have to show me the math here. And you can bet your derriere that the shark will be eating you. So if you come up with a result where the shark is not eating you, you probably did something wrong. Let's actually get right to it. And one of the best ways to do this problem is to kind of draw the setup. And we have shore, right? This is the safety. This is the shore. And you are 40 feet from the shore. And you're relatively sad because you're about to be eaten by a great white shark. You can swim at 3 feet per second. And way out here, 150 feet away from you, 150 feet away from you is this very hungry and big, giant, nasty, mean shark. And shark's coming after you. The shark can swim at 35 feet per second. So one way we can solve this problem is kind of figure out how long it would take you to swim to the shore versus how long it would take the shark to get to the shore. And if the shark can swim this total distance to the shore before you can, obviously the shark is going to eat you. So we know that speed equals distance divided by time. And hopefully at this point you realize that time can be brought up and the speed can be brought down. Time equals distance over speed. And we have all of these variables for both you and the shark. So for you, how far do you have to swim? Well, you have to swim 40 feet. So time, which equals distance over speed, is going to equal 40 feet divided by your speed. And your speed is 3 feet per second. So it would take you 13.33 repeating seconds to get to the shore. 13.33 seconds. How long would it take the shark? Well, same thing. Time equals. And this is where some of my students are going to make a mistake. You're going to put 150 feet in for the distance the shark has to swim. The shark is 150 feet away from you. If we're calculating how long it takes a shark to swim to the shore, we need to add 150 feet to 40 because the shark is actually going to be 190 feet from the shore. The shark is 150 feet from you, and you're 40 feet from the shore. So the distance here is going to be 190 feet. Speed of the shark is 35 feet per second. And when you put that in your calculator, we get an answer of about 5.4 seconds. So it would take the shark 5.4 seconds to get to the shore. It would take you 13.33. Obviously, the shark is going to eat you. The shark could probably swim there and back and there again and eat you. It's very fast. So he's coming in and you're basically fish food. So that's the shark problem. Just remember when you do this to add these distances. If you don't add these distances and treat it as a time problem, you won't get the answer right. So the shark will eat you. And let's take this same problem and extend it a little bit. And suppose you're swimming in the ocean, the shark's 150 feet away from you, you're 40 feet from the shore, you swim at 3 feet, the shark swims at 35 feet per second. I'm changing the question now. How long do you have left to live? So I want to know how long it is before the shark's actually going to catch up to you. How much time on this earth do you have left? And I am asking you time, right? So time equals distance over speed. And what I'm going to tell you to do is I'm going to tell you to treat this, we're going to simplify this problem. Imagine you were running this way at 5 miles an hour. And imagine somebody was chasing you at 5 miles an hour. Would this person ever catch you? I don't think they would ever catch you. You're both running off with the same speed. You're going to be the same distance apart. That person would have to be running faster than you to catch up to you. And I think that's common sense. And what we can do is we can look at this shark problem. The shark swims 35 feet per second. That way. And you're swimming 3 feet per second that way. And what that means is the shark, if we kind of took a difference here, the shark will be catching up to you at a rate of 32 feet per second. So we can simplify this problem and kind of treat it statically. We can say that the shark is going to be catching up to you at a rate of 32 feet per second. Why? Because you're going 3 and the shark's going 35 in the same direction. So 3 of these are going to cancel with 3 from the shark. So if we start with the assumption that the shark is moving 32 feet per second, we can make this problem really easy. Speed equals 32 feet per second. How far is the shark away from you? Shark is 150 feet away from you in the problem. And again, we don't have to worry about anything else because we're canceling 3 feet per second from you with 3 feet per second from the shark. So we can almost assume you're stationary and the shark is catching up to you at 32 feet per second. So time equals distance divided by speed. And if we were to calculate that, it looks like it's going to be around 5. 4.7. So the answer to this question is 4.7 seconds. That's how much time you have left to live. And I hope we see that because you're going 3 this way, the shark's coming 35 after you, it's only catching up to you at 32 feet per second, and we can really simplify this problem a lot. And again, it's a time problem. So that's how much time you have left to live. And of course, you have an assignment. While on vacation, you get out of your car to explore the African wild. You didn't realize how far away from your vehicle you had wandered when suddenly you spot a lion about 200 feet away from you. Oh no. You immediately begin to run towards your car, and the lion darts after you. Your car is 80 feet away, and you can run at 19 feet per second. The lion can run at 70 feet per second. Will you make it to the car, or will you be kitty food? And how long do you have left to live? So solve both of these problems, or solve this problem getting both answers just the way we did the last one. Figure out how far your car is, how long it takes the lion to get to the car versus how long it takes you to get to the car. And then figure out the speed at which the lion is catching up to you, and you can calculate both of these things. And take your time and do this well, because you will have one of these questions on a test. It might be a crocodile chasing you in the Nile, or I don't know, a giant anaconda, or maybe even a mean snapping turtle in the global. I'll just make something crazy up as I imagine you getting eaten by wild animals. But anyway, hopefully this helps you with some speed and velocity, or speed, distance, and time. Slightly more complicated problem for my freshman physical scientist. This is Mr. Zapone. I'm out.